The sulfur cycle in agriculture. For more multimedia content on farming, please visit our YouTube channel or Yara website. Introduction. Sulfur, as nitrogen, is a vital ingredient for crop growth. Often linked to each other in biological processes, both elements form an inseparable team. However, if sulfur deficiencies were fairly rare 20 years ago, they are commonly encountered today due to the drop of sulfur dioxide emissions. Thus, sulfur has become a main concern in agriculture today. The following animation explains the sulfur cycle in agriculture. Sulfur can be brought to crops by application of mineral fertilizer or manure. It is also available in soil organic matter and in the atmosphere. Sulfur can only be absorbed by plant roots as sulfate or, to a lesser extent, by plant leaves as sulfur dioxide. Sulfur from fertilizers. Mineral fertilizers contain sulfur as sulfate. Unlike organic sulfur compounds from manure, sulfate from fertilizer is immediately available as a nutrient and easily absorbed by plants. Uptake of sulfate is rapid due to high particle mobility. Sulfate is mobile in the soil and reaches the plant roots quickly. Transformation of sulfate into sulfite is favored by lack of oxygen, waterlogging. Soil bacteria convert sulfate into gaseous hydrogen sulfide. This could cause minor losses to the atmosphere through volatilization. Organic sulfur. Application of manure, containing sulfur mainly as organic compounds, will enrich the soil organic matter pool. Immobilized sulfur is not immediately available for plant uptake, but needs to be mineralized first. Mineralization of soil organic matter to sulfate is a slow process. Only a small part of sulfur in the soil is mineralized during the growing season, mainly during late spring and summer. Transformation of organic sulfur into hydrogen sulfide is favored by lack of oxygen. Anaerobic fermentation converts organic sulfur into gaseous hydrogen sulfide. This is lost to the atmosphere by volatilization. Most volatilization losses from manure occur during storage. Sulfur from the atmosphere. Sulfur from natural events, volcanic eruptions, or man-made activities, burning of fossil fuels, can be found in the atmosphere mainly as sulfur dioxide. Sulfur dioxide from the air can enter the leaves of plants, but most of the atmospheric sulfur enters the soil through rainwater. Sulfur deposits from the atmosphere have reduced by more than 80% since the 90s. As a consequence, atmospheric deposits are marginal and hardly exceed 10 kilograms of sulfur per hectare today, far less than most crops need. Leaching. Sulfur behaves similar to nitrogen in the soil. Sulfate ions, as nitrate ions, are dissolved and prone to leaching. Leaching of sulfate occurs mainly during winter and fallow periods, when percolating rainfall washes residual and mineralized sulfate below the root zone. Fertilization should therefore be matched to plant growth in order to ensure rapid uptake. Uptake dynamics. Uptake dynamics are an important aspect of sulfur nutrition. Sulfur is required at all stages of the growth process. During the growing season, sulfur needs for demanding crops such as rapeseed and wheat exceed by far the sulfur supplied by the soil. Conclusion. Sulfur is one of the 6 nutrients essential for crop growth. Sulfur deficiencies are often hidden and limit nitrogen uptake, reduce yield, protein content, and general crop quality. Formerly, sulfur dioxide emissions from industrial origins guaranteed sufficient and automatic sulfur supply. Environmental regulations have strongly reduced such emissions. Today, high-quality and high-yield strategies require a careful adjustment of fertilization to sulfur needs. For more multimedia content on farming, please visit our YouTube channel or Yara website.